for having me today. I'm having a blast today because most of us are working on the same subjects, and it's really interesting to see all these people coming together working on this mobility data. And I'm going to present today the results of our projects working on mobility data. We have been working on mobility data, especially on GPS data, something that Letitia also presented, and the previous speaker also presented, but also on CDR. So this is a project that has been working. We have been working 3 years, but during the COVID times, we actually recycle our let's say research. We started doing things also in that space. So wherever you go, if and I'm bringing today here, for example, this report about the future of cities of 3 years ago, before the pandemic, actually. Wherever you go, you see that cities are becoming much more important. Urban areas are becoming much more important, not only because of by 2050, for example, the predictions are that 75% of the people are going to be living in a city, but also because cities are becoming the place in which innovation, in which demographic changes, in which culture is happening, etc. But obviously, cities have a number of problems, and I'm bringing here, for example, this report by the European Commission, but you can see many other reports that the fact that we're living together in small spaces is creating problems like, for example, environmental impact. 75%, for example, of CO2 is produced by cities. Cities have a problem of aging, obviously housing. Most of you that probably are renting or buying a house in the city know that there's a problem of scarcity and prices, etc. A new force of governance, for example, cities are becoming much bigger, and having only one centralized government probably makes no sense to run the cities. So we need no forms of governance. Mobility is also a problem or an opportunity. We have seen in the last years how people have changed completely the way they move around the city, using different multimodalities, different modalities, etc. But I'm bringing today here, I'm going to talk about the other 3 problems that I think are interesting because of what has happened recently, but also because they are the ones that probably are behind or the root of all the rest of the problems. One of them is about social segregation, the fact that we live in the same city, but we live apart. The other ones are labor markets. The offer and the demand, the supply and demand of jobs in the cities is not very well shared throughout the different groups that live in the city. And obviously, during the last years, we have seen that the fact that we live in cities, we live in highly dense areas, and we share the space and the places and the restaurants and the areas with many people, have created another problem, which is the problem of transmission of diseases, and especially the problem of epidemics. But when I started talking about, for example, social segregation on labor markets or epidemics, most of the approaches to understand these problems in cities have to do with places. Most of the things that you see are talking about libraries, are talking about parks, are talking about roads, are talking about where people live, etc. So, most of the discussion is about, for example, in social segregation, is about where people live. So you see this area is highly segregated, or this neighborhood is highly segregated, etc. But I'm going to try to convince you today that actually what's happening in the city is the mixture of 2 things. Probably you know this. I'm not that revealing something which is super new. Is that most of this happening in the city is the combination of 2 things: the places, which are still important, but also the behavior of people, and the fact that we move around and do things which are far away from where we live. Let me come back to what we mean by in our research by mobility data. So you have seen probably in the last 2 talks this morning or this afternoon, you have seen many different mobility data sets that are coming from mobile phones. There are many other mobility data sets, public transportation, commuting surveys, etc., that have been used to understand problems in the cities. But in the last years, the access to mobile phone data has completely revolutionized the study of cities. There are many different spatial and temporal scales that are all coming from mobile phone data. And you have seen, for example, Letitia talking this morning about the CDRs, and also Charisma talking about CDRs. This is typically when you make a phone call, your mobile phone connects to an antenna, and that antenna reports your location. Basically, is the location of the antenna. The temporal resolution is typically between 30 minutes, although, for example, in the US, this is actually increasing because people don't make mobile phone calls anymore. And the typical resolution is about 100 meters to 1 kilometer. So this is very good, for example, for transportation problems. The typical thing about understanding how many people go from Liverpool to Manchester every day is very well approximated by CDR. Tourism is another industry which is benefiting from CDRs because you have also where these people are coming from, the country, etc. On the other side, we have the GPS data that is coming from apps. Typically, these apps are location-based services. Like Lydia was talking this morning, for example, about Cubic. These companies actually provide you a service, and they need your location to provide that services. And the typical resolution of the GPS is about from 5 meters to 20 meters. And typically, because these applications run in background, you get the location of people every 10 to 25 minutes. And the ultimate, let's say, spatial resolution is Bluetooth, which is that when two mobile phones are very close, into the range of 1 meter to 10 meters, then they have a connection. The temporal scale is, I mean, whatever the temporal scale of the Bluetooth is, it depends on the application and also on the mobile phone and the operating system. But you can see that there are different spatial scales and different temporal scales, and depending on the problem you have in mind, you can use one or the other data sets. It's actually, can I use, for example, CDRs to understand urban segregation? Yes, you can, but the resolution that you can achieve to understand that problem is only about hundreds of meters or about kilometers. Can I understand, for example, contact tracing using CDRs? Probably not. You need either Bluetooth or you need GPS. So depending on the problem you have in mind, you can actually use one of the others. One of the things that I would like to mention is critical in our research is that every data that we are going to use is biased. Sorry. Is biased, and this is crucial because we are going to try to understand segregation in cities, and the fact that the data is already biased means that there is already a segregation in the use of this data or the use of mobile phones, and we don't want to propagate that segregation or that inequality in the access to CDR, GPS, or Bluetooth technologies into the analysis that we're going to do. I'm not going to go through the details, but you can see on our papers. There are many methods to do that, and people working in social sciences have been doing this for ages. You can use pre-stratification and post-stratification methods. They don't solve completely the problem, but at least you can approach, or you can actually approach the answer, the final answer about how biased is this data and how to de-bias this data. So let me talk to you about the first project that we have been doing, which is about segregation in cities. So one of the things that when you look at segregation in the cities, it's pretty much what's happening in social media. Cities are basically one of the biggest social machines that we have. Everybody's talking now about social media, but actually most of our relationships happening in places and happening in the cities. And one of the problems that we have seen in the last years is that the social fabric of cities, pretty much like what's happening, for example, in social media, is becoming polarized. So you basically end up talking and spending more time with people which are very alike, very similar to you, and that is creating a problem that people don't communicate, people don't share information, and people actually don't share opportunities, etc. And this is becoming a problem, especially for the people which are living in more vulnerable populations. And not only because of this, let's say, polarization and the fact that our democracies or our societies are becoming more polarized, but also segregation has an enormous cost. It's actually money. At the end of the year, most of the cities have that have a lot of social segregation have an economic burden because they are segregated. For example, areas and cities with high segregation, they have higher homicide rates. They have a slower economic growth, and in the future they're going to be less innovative because people that are not segregated are not sharing opportunities, innovation, ideas, etc. Of course, most of this cost is for the people which are living in the most segregated areas. The people, for example, in the United States, people that are living in most segregated areas, they can live up to 10 to 15 years less. So this is actually impacting let's say, the life expectancy. And of course, the people that are living in segregated areas, they have fewer years of secondary education. So this is not a problem that is moral or ethical. This is also a problem that is economical. I mean, the fact that we live segregated is putting on a cost to our cities, and this is actually something that we want to address and solve eventually. But what I was saying is that most of us, when we're talking about segregation, we have this picture. This is actually a very nice article about visualizing inequality using drones. And you have, this is a picture of one area in Mexico City, and you can see that when you talk about segregation, most of the pictures that we have in mind is this. You have an area which is on the right-hand side, which seems to be nicer. I mean, because of the materials, the arrangement, the street, the trees, etc. And one on the left, which is slum-like, and it's probably poor. So when you talk about segregation, this is what you have. This is the rich areas living very close to poor areas. But there's no information about what people is doing here. You don't have information about this. Is the people on the right-hand side going to the left-hand side? Is the people on the left-hand side going to the right-hand side? It's actually the trees that you see in the middle of a rear for preventing people from going from one side to the other. Are people on the right-hand side communicating with the people on the left-hand side? So in order to understand this question, for the last 2 years, we have been looking at cubic data. This data comes from cubic, which is the same data that Laetitia was presenting. The data that comes from location-based services. We have about 5 million people in the US in these 10, 11 metropolitan areas. And we have a lot of mobility data. So basically, we have traces of how people move around the city by day. And the other thing that we do is to actually attribute this data to visits. So people that are spending time in places using a data sets of 1.2 million POIs, points of interest. So basically what we can see is that what is the journals of people through the day. I mean, what they have spent time, they're at home, they go to a restaurant, they go to the workplace, they come back to pick their kids from school, etc. So we have all the, let's say, the mobility patterns of people through the day. And one of the things that we found is that 75% of the people that you find every day in the United States lives more than 15 kilometers away from you. So if we are going to talk about segregation and the fact that we are living actually apart from each other, maybe we have to start thinking that it's not where we live, it's what we do, what matters. So if a person is segregated in the sense that it's only accessing a particular socio-demographic group through the day, maybe this is not because where they live, maybe it's also because where they go, what they do. Okay, so this is our project. The project is we want to understand where and why this is happening. We have published recently the paper about the results. You can find it here, and this is the two things. So we want to understand where is segregation happening, because most of us are actually exposed to people from all over the place. So if there is segregation, where this is happening, and the other reason is why this is happening. Why there are some people that, despite being far away from where they live, they are still segregated. Okay, let me talk a little bit about the data again. So the data, as I was telling you, we have the trajectories of people. So using the trajectories, we can identify when a person, for example, gets into a pizza place and how much time this person spends in this pizza place. We can actually compute the socio-demographic profiles of the people that are visiting this place. And using the socio-demographic profiles, for example, income here, we can get the distribution of time that different socio-demographic groups spend in that place. And we can quantify how unequal is that place by looking at the distribution of this time that different socio-demographic groups spend. For example, in this restaurant, the pie, if you assume that this is income, most people that visit this place come from the high income group. And there's few people that come from the low income groups. Well, as you can see, the inequality that we are describing here is pretty much like getting the Gini coefficient of a place. And it's actually a measure which, I mean, traditionally in the census is called the isolation or the exposure that different groups in the city have to other groups. Well, we did many, in the paper you can find many definitions of inequality, but we did something which is very, very simple to understand. Because we have divided the groups of people in our data set into 4 equal size groups. A place which is very equal is the one in which you basically find people from all over the place, I mean, from across the board. So you can find people from low income groups and you can find people from high income groups with the same probability. And a place which is very unequal is a place in which most of the people visiting the place come from one socioeconomic group. Okay, so this place, for example, is very unequal. You can find in the paper many definitions of inequality. Our results do not depend on the actual definition. We have used entropy, which is another thing that you can think about. We have used isolation. We have used exposure. I mean, all the census measures of inequality that you might think. The first thing that we did is, okay, now that we know how unequal are the places, the question is if there is any particular institution in the city which is playing the role of putting people together. And if there are places that unfortunately are becoming barriers for putting people together, for accessing other people from other income. And you can find actually the results of this research in our Atlas of Inequality. This is a platform where you can see these 1.2 million places. Each of the dots that you see here is a place in the United States, which is colored according to that inequality. This is New York. For those of you that recognize, this is Manhattan. This is Central Park. And you can see a lot of reddish points, let's say in the suburban areas, like in the poor areas like the Bronx, Queens, and Brooklyn, Newark. But you can also see a lot of bluish points very close to the city center, Manhattan, downtown, and in most commercial areas. Okay, something which is expected. But we found two things which were unexpected. The first one is that even though you see a lot of reddish points which are close together and a lot of bluish points stuck together, if you zoom in, you can always see a reddish point close to a bluish point. You can always see a place which is highly segregated next door to a place which is highly integrated. In the sense that if you go to this coffee shop, which is highly integrated, you will see people from all socioeconomic groups, all income groups. While if you go to the other one, you will see people from only one income group. This is, for example, the place where I usually go for lunch. This is the Media Lab is around here, and this is Main Street. You can have two restaurants here. One is the Clover Food Lab, and the other one is Chipotle Mexican Grill. That have very different inequality. One is more unequal than the other. And these two places are 50 meters away from each other. And those two places are actually, you can have a lunch for $15. So it's not the price. For those of you that are working on a more technical, let's say, way of describing this thing, we have done the spatial autocorrelogram of the segregation. And you can see that despite the spatial autocorrelogram of income in cities is very high, so you have to travel 1 kilometer to see people of all income. The place segregation is actually around, let's say, 50 meters. The place segregation, the spatial correlogram of the place segregation drops to 0.4. So meaning that with probability 0.4, the correlation, the inequality of the place is totally different. So this segregation is happening in 50 meters. It's actually happening across the street. You can cross the street and you can go to a place which is totally different from the place where you when you have this different segregation. One thing that actually matters is the category, the type of place. So this is a complicated plot in which each of the points that you see here is a category, is all the places in the United States that belong, for example, to a school category, or all the places in the United States that belong to a warehouse category. And this vertical axis is the average place segregation. Okay, and you can see that there's a lot of variability. You can go from the most segregated places in the United States on average, which are the check cashing and the pawn shops, to the less segregated places in the United States, which are science museums. These are the less segregated places in the United States, not museums in general, but science museums. And on the horizontal axis, you have the accessibility, meaning what is the distance that people have to travel to get to those places. Of course, there's only probably one science museum or two in the city. Okay, so you have to travel a lot to get to the science museum or a gate of the airport. You see that there is a lot of correlation between the accessibility and the segregation, which is something expected, because more, let's say, ubiquitous places, they are local, like for example, grocery stores, supermarkets, and elementary school. But not everything is explained by accessibility. For example, have a look at the workplaces. Everybody commutes around 15 kilometers every day in the United States to work, to go to the workplaces. But if you work in an office, you're probably less segregated in your daily, let's say, exposure to other income groups than if you live in a workhouse or a factory. If you work in a workhouse, it's like if you stay at home, as segregated as if you stay at home. Okay. The category matters so much that even the type of food that you like matters. So this is the same plot for the type of restaurants in the United States. And you can see the same thing, average segregation and the average distance from the users of home. And you can see that most of the fast food is actually the highly segregated places. Spanish, Caribbean, Latin American food, fried chicken, southern, Chinese, donuts, tacos. I mean, most of the food, which is fast food, is highly segregated. And well, there's something that we found is that the Tex-Mex is actually the places which are less segregated in the United States. So what I'm saying is that there are particular institutions, particular places in the cities which are creating these opportunities for people to get together. I mean, for different groups to get together, and there are other ones which are preventing that and actually become barriers for that social segregation. But the most important thing is the why. I mean, why are people segregated? Why are people experiencing this different segregation? So what we did was to extend this analysis instead of places to individuals. So instead of computing what is the amount of the distribution of the people that go to a place, we computed the distribution of people that you see every day. So that an individual sees every day. So this could be me, for example. I'm going to this restaurant, to another restaurant here, and this is the place where I work. This is the MIT Media Lab. And this is the people that usually visit those places. So using these distributions and the amount of time that I spend in those places, I can compute the distribution of the people that I see every day. Okay, and I can compute how unequal is my experience, segregation every day. So for example, in this case, 40% inequal. Of course, one of the things that you know is that the mobility data is one of the most studied. The mobility in urban areas is one of the most studied problems for computer science, social sciences, transportation, and also computational social science. There has been many models to try to understand how people move, what are the decisions that they make, how they visit places, how they regular visit places, how they come back to their really visit places, etc. So what we are going to do is actually, in order to explain this number, this inequality number, we're going to use a model which is called the exploration and preferential return model that explains how people visit places in their cities and the amount of time that they spend in different places. This is a very simple model. It's not a model that explains why people go to those places. It's a model that encodes the mechanistic, let's say, process of how people visit places. And at the end of the day, it explains very well the amount of time that people spend in different places. The model is the following, is that every time that person is in a place, she decides to go to another place. And that is actually happening with probability P nu here, which is actually the inverse of the number of visited places. So the more places you have visited, the less probability you have to visit another place. And with probability 1 minus P nu, the person decides to come back to already visited places, which is called what we call the preferential return. Okay, so either you explore or you exploit. Either you explore new places or you exploit the already visited places. The preferential return means that you come to the places which you have already visited more, with more probability. Okay, this is very simple to understand. The good thing about this model is that it reproduces that for us, for the average people, 80% of the time, you spend 80% of the time in 5 top places. Okay? So when you talk about mobility, you have to encode the fact that we are very unequal, that most of our time is spent in a very small set of places. The problem with this model is that it doesn't explain segregation, because if you choose a new place with randomly in the city, you're basically bound to, I don't know, be exposed to different people in the city. So what we did was to combine this model with the Schelling model of segregation. And the Schelling model tells you that people are more comfortable sharing the space, the neighborhood with people which are similar to them. So when people visit new places, we introduce a new parameter, which is called this sigma s, which is this Schelling parameter, in which they visit places in which the majority of the people there are on the same income as they are, or with probability sigma s, they explore places which are of different, let's say, income composition. Okay, we are not explaining why. We are just encoding this mobility behavior into new parameters. One is the probability that people explore new places, and the other one is that they actually explore places which are different socially. Okay. These two parameters as well we call the social exploration and the place exploration. Place exploration tells you how many places you go to, new places you go to, and social exploration explains with the willingness that you have to explore places which are of different, let's say, income composition as yourself. Okay, this is the distribution of the sigma p and sigma s that we found in our data. I mean, most people on average are, let's say, have a parameter which is 0.5 of place exploration, but most people are actually very social explorers. Most people are actually sharing the space with the people that have or are from many different incomes. Although there is a large fraction of people that are less willing to actually go to places of different income composition. The good thing is that we can actually now try to explain the segregation by looking at the demographic and mobility reasons why people have these different sigma P and sigma S. So this is what we did. What we like to actually try to explain is why people have different sigma S, sigma P, and as a result, why do they have different segregation? Okay, and we did this by using hedonistic models that use residential demographics, geographical mobility, and also the type of places that visit. Because as I was telling you, if you spend most of your time, for example, in fast food, you are bound to be more segregated than a person that goes to other types of food. What we found is actually quite striking is that the place exploration, the fact that people decide to explore new places, is mostly encoded into the type of places you visit. For example, knowing your income doesn't tell me anything about whether you are a social explorer or not, but knowing that you like theater tells me that you're a social explorer. So most of the percentage of variation, for example, in sigma P, most of the percentage of variation can be explained by the behavioral features, by the places you visit and how you move around. On the contrary, most of the willingness to explore places of different income groups is encoded into the residential demographics, is encoded into the race, poverty, employment, education, and transportation properties of the place where you live, which probably are similar to the ones that you share. As a result, you combine these two, the social segregation, I mean, the exposure that you have to different groups in the city can be explained both by this behavioral fact, the people that are willing to explore places, and this social segregation part, which is people willing to explore places that are of different income groups. I'm not going to go through this, but for example, one of the things that can tell you that you are a social explorer is that you like tapas. I'm from Spain, so that's something good. I mean, like, now I like tapas. One of the things that I can tell you, for example, that you are not a social explorer is that you are heavily involved into education. Like, for example, you spend a lot of time in schools, or that you spend a lot of time, for example, working in a factory, on a warehouse. But one of the things that, for example, that tells me that you are a less social explorer is that you live in a community which has a lot of African American community, or that you have less access to public transportation, you use more to public transportation, or you have more multiracial. But you see that these blank areas here tells me that social exploration is not explained by the type of places you go to, and the place exploration is not explained by the demographics. Okay, so this is a very important result because it tells you that if we try to understand how people are segregated in the city, only 10% of the variability in social segregation is explained by income. Okay? It's not explained by the place where you live. It's mostly explained by the behavior, the places you go, the choices. Sometimes it's not choices, it's also opportunities, and also the mobility patterns. So at the end of the day, you want to change people, the exposure of people to different behavior, to different people. Maybe we have to start changing this part here. Okay, I'm gonna go through very quickly for the last part, which is epidemics. We have also been using, as Latita was saying, we've also been using this data to understand epidemics in the city. Let me tell you something is that the good thing about mobility data is that actually, when you try to explain epidemics, is the combination of two processes. One is the contact network. I mean, the fact that the virus cannot spread if people don't get together. So the only way that the virus spreads is when people get together. And the other one is the transmissibility. For different viruses, the transmissibility is different. And what has happened is that during the last years, we have seen that a lot of interventions in both the contact network, like for example, lockdowns is basically a way to prune the contact network, to reduce the contact network, but also mitigation strategies like, for example, wearing a mask, 6 feet apart, etc., which modify the transmissibility. Okay, the good thing is that the mobility data in the last years has been a tremendous source for approaching or estimating or a proxy for the contact network. And we have actually worked a lot on that because we know where people spend their time. So these two persons, for example, spend time in these 3 different places. So at the end of the day, we can build what we call a contact network between these 2 people happening in a particular type of places. So we can estimate what is the percentage of time, so what is the probability that 2 people are at the same time in cafeterias or in restaurants. And this actually transforms into what we call the temporal contact network. Okay. And with that, what this kind of things that you can do with that? You can, for example, run. This is a paper that we published last year in which we studied what will be the impact of contact tracing. Because we have the actual behavior of people, we can estimate what will be the impact of having one person removed. We can actually do these what-if scenarios of the mobility and remove these people, place it at home, not moving and not visiting the restaurants or the places that he or she usually visits. What we found is that just with 40%, recovering 40% of the contacts using contact tracing actually was going to work. Unfortunately, I mean, contact tracing was not really implemented in large scale in the United States, and this is why we probably have the second wave. But this paper allow us to because we have this high detail mobility data. This paper allow us to do this kind of what-if scenarios. The other thing that we can do is to try to investigate, for example, super spreading events. Because we have this data, we can estimate when and where and who is actually producing these super spreading events. One of the things that we found is actually that no, not everything happens in restaurants. Not everything happens in events. It depends on the city. It depends on the time. For example, in New York, arts and museum were at some point one of the places that were creating more super spreading events, but that never happened in Seattle. That never happened in Seattle. Arts and museums were never a place in which super spreading events were happening at arts museums. And the reason is very simple, is because the mobility data tell us that these two cities are very different in their behavior. For example, Seattle is a more suburban area, and you have a lot of people which are living far away from the city center. And in New York, you have highly dense areas. For example, in Manhattan, where you have a lot of people that live. You can read the results in the paper. And the last thing that we did was you can just to show that you can use the mobility data in very different aspects, is that mobility data can also tell us about when people is walking. I mean, not only when they are coming into contact, but when people are walking. And we have a paper that was published a couple of months ago in which we investigated what was the effect in physical activity of the lockdowns. And what we found is that, once again, that the low-income people were the ones which were more affected by the lockdowns, because most of the physical activity of low-income people comes from going to the workplaces, going to shop. And the fact that the shops, the workplaces were closed impacted them more critically. Okay. So just I mean, I'm not going to go through all the conclusions. I'm just wanted to tell you a little bit about the general idea here is that this mobility data can actually tell us with a high resolution when people get together. I mean, in general, for most of you that are working in social sciences, this is a typical social capital idea, that in the city that there's value in getting together. This idea of third places, the value of places promoting interactions and creating these opportunities, this diversity of ideas, this exchange of opinions, etc. But if we want to create a better society in the future, one of the problems that we found is that the social fabric of cities is becoming less and less resilient. We are becoming more and more segregated. So just to picture this, I'm a physicist, so I like this analogy of using carbon atoms. These two materials that you have here, the graphite and the diamond, are based on the same element, carbon. The only difference between them is the spatial arrangement, is the network, how you connect the carbons. So you want to create cities which look more like a diamond. We have problems because cities are becoming more and more like a graphite. They're more fragile. Okay, and just I want to finalize by acknowledging all my collaborators, and this is a collaboration that is done with the people in MIT, Oxford University, Northeastern, and also a number of companies that we work, etc. And well, these are the papers. And thank you very much. Maybe I extended myself too much. Thank you, and open to questions.
Excellent. Thank you, Esteban, for that interesting presentation and all of those papers. So great summary. So there are actually a few questions, but probably we're not going to be able to cover all of the questions over the Q&A session that we have, so the time that we got. So probably, I mean, I have some questions on my own, but probably I should prioritize here the questions for the audience. So Ed, so on the Q&A box and internally, so one of the panelists, well, a few of the panelists actually got a few questions. So I guess looking at the questions, so Krasen and Ed, so got a very similar question, which is regarding what is capture in one of the papers. So particularly looking at the one on segregation. So Ed asked, So are you able to capture the dynamic nature of social integration, segregation using this data? An obvious issue could be where an office worker never meets the office cleaner despite spatial overlap in areas of activity. Similar, some restaurants offer a cheap lunch and expensive dinners and so on. So I guess the question is, so regarding what is being captured. So is it collocation or, So I don't know, you want to respond to that?
Yeah, that's a very good question. And this is actually one of the limitations that is expressed in the paper is that we cannot, we haven't actually done this distinction of people working in the places and people visiting the places. This is especially important, for example, in restaurants, when, especially big restaurants, when you never see people in the kitchen, for example. But we didn't make the distinction because in some places, this distinction between people working there and people visiting the place is not so, it's not so clear. There are restaurants which are very small, and at the end of the day, you actually meet the owner, or I don't know, you meet the people working there. At the same time, you're saying that you're talking about office worker, but most of us, I regularly see the janitor at the media lab. She's probably one of the most important persons at the media lab that takes care of us and the spaces. So that distinction is not actually very clear in many places, but it can be done. It can be done if we can distinguish about the people which are working there and the people which are visiting the place. And we're having it done because, as I was saying, we in most of the places we don't have this clear distinction about what is happening.
Excellent. So I guess if Alicia allows me, just one final question here from Olin. So thanks. So reading from the Q&A box. So thanks for the great talk, Esteban. I wonder if during the weekends people visit more diverse places on average. Yeah. So basically, most of the exploration happens during Friday night and Saturdays in the cities. So and people actually, so the segregation is actually larger. You can imagine there are different times of the day and different times of the week in which segregation is larger. So especially, for example, early in the morning and late in the nights, segregation is larger because people are visiting mostly local places like the local grocery store and the schools, etc. And there's this famous saying by, I think, Martin Luther King that says that the most segregated place is churches at 11 a.m. on Sundays. This is not true. The most segregated places are actually becoming these schools and the grocery place at 6 p.m. in the afternoons. This is where these are the most segregated places. And especially during the Friday night, Saturdays, and part of the Sundays, yeah, it's true, they are more, less segregation and more diverse. Excellent. So probably, so Esteban, if you are happy to address the questions on the chat box. So yeah, over to Alicia now.